Take a peep. While I'm thinking about it, probably looking at a homework quiz one of these days next week. So I would no, not today. I'm not crazy. I would say that like chapter 6 and 7 stuff would be up for grabs, and up through what we did yesterday would be stuff that I would make sure that I could do for that homework quiz, which seems pretty realistic given that you have a problem set out, all that stuff due this weekend that you should have finished, so you would have had a chance to practice that stuff. Right? So just while I'm waiting to see if anybody has any questions, I figure I'll mention this. Absolutely, we can do 18. Oops. That's okay. All right. So right away, which situation is this? I can tell without even having to draw a picture.
Oh, no, the other one. The one from worksheet 1.
Oh, the worksheet 1. Okay. My apologies.
I was like, what?
Well, you said, I mean, I just, okay.
No, I was just.
That's okay.
I was like, what did you just do? I think they sorted it out.
Nope. I just figured when you said 18, you meant the most recent 18. That's okay, though. Okay. So the directions here ask us to use our half angle formulas. So first order of business to me is going to be to convert pi over 8 into degrees, just because that tends to make life a little bit easier. So I'll multiply by 180 over pi. When I do that, I get 22.5. So now I'll go to my sheet, look for the half angle identities for tangent. Oh no, there isn't one. 22.5. I remember from last chapter that R6 says cotangent is the reciprocal of tangent. Hi. Alondra. So now I'm going to try to write this as a half angle. Well, I recognize that 22.5 is half of 45. So there we're in our half angle form. And we're written as a tangent, so I can use one of the tangent formulas. I'm just going to have to make a reciprocal of it. When I look at the tangent identities, Delaney, I see that there's 3 versions of that. The version that I'm going to choose is version 3, because when I flip it, I'm just going to have sign in the denominator, which means that when it comes time to rationalize the denominator, I won't have to FOIL. But any of them will work. So that's just the one that I'm going to choose. So I'm going to have 1 plus cosine of 45 over sine 45. And that's H3 version 3. At this point, I go to my unit circle. Cosine of 45 is root 2 over 2. Sine of 45 is root 2 over 2. I don't like that I have fractions inside of fractions. So I'm going to multiply the top and bottom by 2 over, or top and bottom by 2. That gets me here. I'll rationalize my denominator, which is nice because if it's just there's no addition and subtraction in the denominator like there is in this case, it's just that. I notice that everything is divisible by 2. So if I just kind of like write that as two fractions with a common denominator, I got root 2 plus 1, which should be my final answer. Now, I scooted through that kind of quickly. Did I lose you at any point, Delaney? That was okay?
It's fine.
Okay.
I can always
Yeah, for sure. I mean, sometimes I just get carried away. I come from the AP Calc class before this, so like details like this, I'm just used to like scooting on, and I sometimes just need a reminder like, hey, slow down for a minute. That's okay. You can always say that if I get going too fast. Okay. Ava. 12 from worksheet 1. Bless you. Bless you again. Okay, so these says to use the power reducings. I know the power reducing ones, though, don't require any like change to my problem. The one troublesome piece is that, well, I don't have a power reducing formula for cotangent, but just like we did for Delaney's problem with cotangent, I'm just going to think about it as a reciprocal of tangent. And now I can use the power reducing number 3. And I'm just going to flip this at the same time rather than writing 1 over PR3 and then flipping. I'm just going to flip it all at one shot. Is that okay, Ava? Okay. So here now I'm going to have the 1 plus cosine 2 times 165 on top, and the 1, should be minus cosine 2 times 165 on bottom. 165 times 2 is 330. So I'm going to go to my unit circle and look up cosine of 330. So I find the 330 on my unit circle, and cosine is the x coordinate. So I have root 3 over 2. I got fractions inside of fractions. So we'll take care of that in the usual way. Now I got a radical in the denominator. Notice here it's the sum or difference with a radical, so I have to multiply by a conjugate here. Again, the conjugate is the same thing as the denominator, just with the opposite sign in the middle. And now I have to FOIL. So the numerator, I get 2 squared plus 2 root 3 plus 2 root 3 plus root 3 squared. The denominator, though, I can multiply that out. I could FOIL it. Or I could use that difference of 2 squares multiplication pattern from Algebra 2. That's what I'm going to choose to use, just because it makes life a little bit quicker. And that sounds pretty good to me. So now let's clean things up. I know the square roots cancel with the squares. So in the numerator, I have a 2 squared plus a 3. That gives me a 7. And then I have a 2 root 2 and another, 2 root 3 and another 2 root 3. That gives me 4 root 3s. And then on bottom, I have a 2 squared minus 3. Well, that's 4 minus 3, so that's just 1. And then 1 over anything is just itself. So that's going to be 7 plus 4 root 3. Yeah, Joe. The one that we just did a second ago? Sure. Hi. Ellie. It looks like a birthday card.
Wow, thank you.
Maybe just Ellie gets a birthday card because she's special. Maybe that's why none of you guys have gotten one. All right. Joey, you said you had.
So when you get 2 over 2, wouldn't the 2's just cancel out?
So you're asking at this step?
No, the very last steps. You get 2, you get the 2, yeah.
That piece?
Yeah. So what'd you do there?
The 2's cancel.
Yeah.
But the root, you can't take something outside a radical and combine with something inside a radical. So it's just like thinking, like if you have 2x over 2, the 2's cancel and you have an x, right?
Yeah.
So you treat it kind of the same way as you would a variable.
So where did you get the 1 plus 1? You
2 divided by 2 is? Right?
Okay.
So I have I have the root 2 coming from that and the 1 coming from that.
Okay.
Does that see it? Okay. Oops. Anybody else? Okay. So let's start on back to chapter 7. So again, let's recap what we've done so far, right? So in chapter 7, we've been talking about solving non-right triangles. We've seen that for the angle-side angle, the angle-angle-side cases, we use the law of sines. And the order of solving the 2 sides doesn't matter. Right? You'd have 2 sides still to find in either one of them. It doesn't matter if you find the shorter side or the longer side first. It didn't matter. The other thing we did was we did side, 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 and side angle side. To do those, we use the law of cosines. And here it mattered, right? When we have 3 angles to solve, we have to find the biggest angle first. We have 2 angles to solve. We need to find the smallest, or the smaller of the 2 angles first. Everybody's okay there? And we had the additional piece that we had to be careful about. That for the side, 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 we have to check if it's even a triangle. That is that the sum of the legs has to be greater than the hypotenuse. If that's not true, the problem's not even possible and there's nothing to do. You just say no triangle possible and you're done. Does that feel okay as a light summary of what we did? Like just kind of the overview of the process, right? What are the little the things we have to be careful about? Where are the little, stuff I have to pay attention to closely, but that's the general picture. So far, so good. Notice that there's still one situation missing that we haven't talked about. That's the SSA situation. That's what we're going to be talking about today. The reason the SSA situation is left for last is because weird things can happen here. These other four situations, if you remember back to geometry, all of these other three situations are also the conditions for triangle congruence. The SSA situation is not enough to show triangle congruence. And that's why weird things can happen. So let's start walking through what can happen. So if I just give you two side lengths and an angle, depending on what the size of that angle and the side lengths are, it may be impossible to form a triangle. You may only be able to form one triangle, or you might be able to make two distinct triangles. So the first order of business is trying to figure out what case are we in? Are we in 0 triangles, 1 triangle, or 2 triangles? The first step in identifying that is to look at the size of the given angle. Okay. So, case 1. The given angle which we're going to assume for our picture is going to be angle A. That angle is greater than or equal to 90 degrees. Okay? Now the two sides that are given if side A is greater than side C, that tells us there's one triangle possible. If side A is less than or equal to side C, 0 triangles are possible. Let's think about why that has to be the case. If angle A is greater than or equal to 90 degrees, what do we know about angle A? If angle A is greater than or equal to 90 degrees, what can we say about angle A? It has to be the biggest angle in the triangle. Everybody agree with that? That you couldn't have another angle that was greater than or equal to 90 degrees because there's only 180 degrees in the triangle and you already have more than half of it in angle A. Everybody's good with that? So if A is the biggest angle in the triangle, what should side A be? It has to be the hypotenuse, meaning it has to be longer than all the other sides, right? So if A is the biggest angle, then side A has to be the biggest side. So if there's another side longer or equal to A, you can't make a triangle with that. Side A has to be the biggest. Is everybody okay with why we're getting 0 triangles possible if A is not the biggest side? Okay. Good there. All right. Our second case is, we'll call as case 2. The given angle, again, we're going to use angle A, is less than 90 degrees. It's acute. Bless you. So in this case, if the side opposite our acute angle is the biggest or equal to of the two given sides, then there's just one triangle. We'll show you in a sec. I'll do this. We'll draw a picture in a second to show you. Now, if A, the side opposite our given angle, is the shorter of the two sides, then we don't know yet what's going to happen. There could be 0 triangles, there could be 1 triangle, or there could be 2 triangles. Okay? This situation here is called the ambiguous case. Because at this point, just having the starting information is not enough for us to tell what's going on yet. We have to do some further analysis to decide whether we're going to have 0 triangles, 1 triangle, or 2 triangles possible. Everybody's okay with that plan? Okay. To show you how to interpret the ambiguous case, I'm going to do an actual example. So let's say we have that angle P is 56, side P is 16, and side Q is 19. I'll start the same way I have been. I'm going to start by drawing my triangle and labeling the side lengths. I'm going to draw in my given information. I notice that we have an SSA situation. Our given angle is acute. It's less than 90 degrees. And the side opposite the given angle is the shorter side. This tells me I'm in the ambiguous case land. Is everybody okay with that? So this is what we do to tell what situation is going on. So we're going to set up a law of sines. So I'm going to have to use sine P over P because that's the only situation where I know both the side or the angle and the opposite side. And I'm going to have to set it up with sine Q over Q because that's the only other situation where I know one of the two. I know nothing about R. Everybody's okay that it has to be that way? And now what I'm going to do is I'm going to get sine Q by itself. So I'm going to cross multiply and divide. I'm going to do that all in one step. So if that quantity there is less than 1, we get 2 triangles. If it's equal to 1, we have 1 triangle. And if it's greater than 1, we have 0 triangles. Notice that I haven't done sine inverse here. I'm just looking at sine of Q. So that is my rule, right? If that sine of Q is less than 1, we're going to get 2 triangles possible. If it's equal to 1 exactly, we'll have 1 triangle possible. If it's greater than 0, we're going to have 2 triangles possible. Or did I say 2? I meant 0 triangles possible, right? I said the wrong thing there. All right. You guys, so let's go ahead and type that into our calculator and just kind of see what we get there. So alpha y equals 19 times sine 56 over 16. Oh my gosh. That's supposed to be greater than 1. Excuse me, guys. And I have the wrong value. What's wrong with what I did here? What did I forget to do before I type something in? And check the mode of my calculator. Right? Why am I getting a negative number there? I had changed my mode back to radians because I was in the calculus class. All right, there we go. So that number is 0.98. So what would we conclude? Nope. Two triangles, right? 0.98 is less than 1, right? Does that feel okay? You guys ready to do an example of this? All right. I'm going to do specifically a two triangle example so you can see if it's zero triangles, like I know exactly what to do. You just say no triangle possible and you stop. If it's one triangle, it's just like the previous problems, right? Not a big deal. Let's do a two triangle example so you can kind of see how do I get two triangles out of this? And like where do I find the second set of values or whatever? Does that sound okay? All right. So again, I'm going to start by drawing and labeling my triangle. I'm going to write in the values that I'm given. I notice this is an SSA case. The given angle is acute. And the side opposite the given angle is the shorter side. So I know we're in the ambiguous case. Some of the homework problems tell you that it's an ambiguous case problem. If that's the case, you don't need to do this verification. I'd still encourage you to get used to going through that criteria to check. It's never wrong to do that extra step, even if you know where it's going to end up. But sometimes I think it's good practice to still do it. Okay, so we're going to start by doing sine of angle B over side B equals sine of angle A over side A. I'm going to get sine of angle A by itself. So again, I'm going to cross multiply and divide. I'm going to do that all in one step unless somebody tells me that that's a problem for them and I should slow down. But I think we did a bunch of examples last time where I did the algebra and it should be pretty familiar, right? At this point, I'm going to pull out my calculator. I'm going to check to see what that is. So 12 times sine 48 over 10. And I get 0.89-ish. Since that's less than 1, it tells me there's two triangles. So what I'm going to do now is I'm going to set up a space on my paper for the work for triangle 1 and a space for triangle 2. Oops. What were those? That's B. B, A. Okay. So those parts are the same in both triangles. The other three distances or angle measures are going to be different in triangle 1 and triangle 2. But the given information is still the same. So far, so good. So in triangle 1, I'm going to finish solving for angle A. So we know that sine of angle A is 12 times sine 48 over 10. How do I get angle A by itself? I do the sine inverse of both sides, right? I'll go to my calculator. Now, that part's already typed in, right? So I'm going to just do sine inverse of that answer, the 89 or 0.89, yada, yada, yada. So I get there 6310. Now, as soon as I have the angle A1, I can find the angle A2. The relationship between angle A1 and angle A2 is always supplementary. So angle A2 is always going to be 180 minus angle A1. That'll always be the situation. The first angle you find in triangle 1 will give you that corresponding angle in triangle 2. So in this case, that's 116.90. Is everybody okay there? Notice in triangle 1, I know 2 of the 3 angles now. So I can find angle C1 by doing 180 minus angle B minus angle A1. Oops. So there's angle A1 and then minus B. So I get 68.90. I can do the same thing in triangle 2, but I have to use angle A2 instead of A1, right? Is everybody okay there? And then angle A2 is the 116. So 15.10 or thereabouts. Are we okay to this point? I want to just take a pause and see how we feel. Is this all right? All right. Let's continue then. To find side C, now I'm going to use a law of sines. So I'm still going to start with my sine of angle B over side B that I was given with. And that's going to equal now my sine of angle C over side C. Everybody's okay with that? I cross multiply and divide. And then I'm going to just grab that answer. So I get a 12.55. And I'll do the same setup in triangle 2. Again, I'll use angle B over side B, which is same. That's the given information. So that's the same in both triangles. But this time I'm going to use my angle C2 to find that side C2. Again, we'll cross multiply and divide. And so I grab my calculator. So 10 times sine of, and then let me go grab that angle C2, divided by sine 48. So 3.50-ish. Is everybody okay with what we did here? Let's do a quick little check on our ratios to make sure that this makes sense. So if I look in triangle 1, the smallest angle is angle B. The smallest side is side B. The medium angle is A1. The medium side is A. And the biggest angle is C1. The biggest side is C1. So triangle 1 makes sense. Looking at triangle 2, my smallest angle is C2. My smallest side is C2. My medium angle is B. My medium side is B. My biggest angle is A2. My biggest side is A. So again, that all makes sense. So at this point, we should be pretty confident that we have the correct outcome here. Is everybody okay walking through this? All right. Let me do this for you guys. Luca had kind of asked an important question, like how is it possible we're getting two triangles out of this? Let's kind of show you geometrically here. Come on. What's going on? So let's look at that last situation. All right. Okay, sorry, I don't want to do that yet. I'm going to do a line. And then I'm going to do a distance. Oh, that's not what I wanted it to do. Oh, I'll do that. All right, let's do this. Right. And then let's draw that. Distance. Then 48. And I'm going to put a point. Oh, can I just move B? But I can do that, right? No. Okay. All right. Okay. Then I need a 12. I'm so dumb. All right. Okay. So if we look, let me just actually hide you, make data segment. And then IDU. And then make segment. Okay. And then we'll do that and that. Okay. Okay. So if I look here, here is my hold on, this isn't working the way I wanted it to. Yes. All right, I've already got this. Okay. So here's like the situation we just looked at, right? So like here's our SSA situation where we have 48, 12, 10. So one of the triangles can look like this, right? And if I scroll here, where is it? The other triangle could be here, right, where we're just about 10. Do you guys see that? So like I got another triangle that we made that's like the one with the 116-degree angle in it. Can be, 48, 12, 10, and now it's here. Or if I scrolled back, it could have been 10 would have been about here, right? So two triangles possible based on those dimensions. Does that make sense as to what we're seeing? As to why? Should we do another example of this? Yeah. What do you talk when you say how do you know there's two triangles? You mean in the problem or the picture I just showed you? So because it was an SSA case where the given angle is acute and the side opposite the given angle is the shorter side. And then when we do the law of sines, the sine of the angle in question is less than 1. All of that stuff has to come before it. All of that stuff had to happen for there to be two triangles. So it had to be SSA, have to have an acute angle given. The side opposite the acute angle has to be the shorter of the two sides. and then the sine of the angle of the longer side has to be less than 1. So all that stuff had to happen, but that's the only time you can get 2 triangles is that way. Should we do another one? What do you guys think? Yeah? All right. Let's do one more. Yes. Oops. So this is number 11. Actually, let's do this. This will be number 12 from the homework. The directions say that 2 triangles can be formed and to solve for them both. I'm going to also verify that there are 2 triangles just so we can walk through that process again, because that can be challenging on its own. So I would like everybody to give me your best attention. This is the hardest thing we have to do in Chapter 7. So let's just kind of all try to follow along the best that we can. Whoever's playing the absurdly loud headphone music, if you could please turn that off, that would be great. So I'm going to start by drawing and labeling my triangle. I'm going to add in the given measurements. I notice that this is an SSA case. I notice the given angle is acute. And I notice the side opposite, the given angle, is the shorter side. Everybody, well, 38 degrees is less than 90, right? The side opposite that is the shorter of the 2. So we are in the ambiguous case. From there, we set up our law of sines. The only law of sines setup we can do is sine B over B equals sine C over C. Oops. Because I know nothing about angle A or side A. It's the only law of sines I can possibly set up is this one. So I cross multiply and divide. And I'm going to go to my calculator and compute what sine of angle C is. What I get is 0.73-ish. That's less than 1, which tells me 2 triangles. Is everybody okay there? I'm now going to divide my paper into 2 sections. One section for my work for triangle 1, and one section for my work for triangle 2. I know that in either case, I know that angle B is 48 degrees. Side B is 20. What's up?
How does it go? You guys just did one triangle last class? 0? Because these are 2 triangles?
Yes. So last class, everything was either 0 or 1 triangle possible.
Yeah.
There's only, the SSS is the only situation where you can get 0. And that check for that is just that the sum of the legs has to be greater than hypotenuse, which is easy because it's just arithmetic.
You posted that, right?
The lesson? Yes. Okay, so I've set up my divided sheet. And now I'm going to start with where I left off above. So angle C1 is going to be the sine inverse of that 73 or 0.73 that we just computed a moment ago. So 0.4713, or sorry, 47.13. And now to get angle C2, that is just going to be the supplement of angle C1. Always the most common mistake I see students make here, 132.87. Is that they find A1 next, and then they do the supplement of A1 also. It only works for the first angle. Has to be the first angle you solve. In triangle 1 will give you the first angle in triangle 2. The third angle, the supplement of it, will not give you an angle in the triangle 2. Is everybody okay there? Now in both triangles, we have 2 of the 3 angles. So to find the third, we can just do 180 minus the other 2. So in triangle 1, that's 180 minus 48 minus that 4713. So we get 8487. In triangle 2, I have 180 minus 48 minus that 132.87. Oh my goodness. Guys, look at what I did. It's not 48, it was 38. Ugh, Mr. Kulik. Great googly moogly. All right, I gotta go all the way back and see if I made that mistake back here. No, I didn't. Okay, well that's good. All right. So that guy should be 94. And this one I'm gonna fix for realsies. So 9.13. Everybody's okay? Sorry about the mix up there. I was still doing the previous problem where we're using a 48-degree angle or something. Now to solve for side C1, or I'm sorry, for side A1, Jeepers creepers here. To solve for side A1, I'm going to set up another law of sines. So I'm going to do sine of 38 over 21. That was my given stuff, equals sine of my new angle A1 that I just found, 94.87, over side A1. Cross multiply and divide. I get that. I don't think I have 94.87 in my calculator anywhere, so I just had to type in the decimal. Over sine 38. So I get 33.99. And if I look at the angles and side length ratios in triangle 1, that all looks good. Smallest across from smallest, middle across from middle, biggest across from big. We'll do the same thing now in triangle 2. So I'll do sine 38 over 21. The givens are the same in both triangles. Equals sine of angle A. Yep. A2 over side A2. Cross multiply and divide. And calculator time. So 21 sine of 9.13. I'll take the whole decimal over sine 38. So here we get 5.41-ish. And again, if I check biggest across from biggest, middle across from middle, smallest across from smallest, that looks pretty good. I'm quite happy with my result here. This is the worst case scenario kind of problem, is where you end up with like these 2-in-1 kind of problem. This is all I want to do today. This is enough for one lesson. This is a complicated idea. There's a lot of things to have to check. For homework, I'd like you to do, again, chapter 7, 1 through 14.
You wrote it last.
I'm sorry, 11 through 14. Okay. Those are all two triangle problems, but you're in luck, because what do you already have done? 12, right? I did that for you guys just here now. This homework is not due until the 21st. From chapter 6, I wanted you guys to do, what did we assign already? It's like 1 through 10, and then like 23 to 26 in worksheet 1, right?
Yeah.
And then chapter 7, we assigned 1 through, what was it? Oh, goodness gracious. That should be 5 through 14. 1 through 4, and then 15 to something else. 23, 22. This is due, well, I would say the Sunday, but we don't have school on Monday, so like might as well just make it Monday at midnight, because I'm not looking at anything until I get to school on Tuesday morning. So you guys take an extra day. So just FYI on this most recent homework, the 5 through 14 there. 1, 5 through 10, all it's asking for is 0, 1, or 2 triangles possible. Don't solve for the triangles. Just get up to that sine part, where you do sine of angle, whatever. And if it's bigger than 1, equal to 1, or less than 1, say what happens and you're done. Stop. Don't do any more. Right? Those should be relatively fast. There's not so much to do there. And then 11 through 14 are all 2 triangle problems that we're asking you to solve for both triangles. On a test or whatever, this would be the kind of way I would ask for things. I would ask like 0, 1, or 2 triangles and give you stuff and not ask you to actually solve the triangle. If I did ask you to solve a 2 triangle problem, I would tell you it's a 2 triangle problem and ask for both sets of answers. So I wouldn't give you a solve for the triangle and stick a 2 triangle problem in there without telling you it's a 2 triangle problem in the direction. Is everybody okay with that? What else should you expect next week? Homework quiz over chapter 6 stuff and then 7.1 and 7.3. Not what we did today. Okay, we still have one more section to do next week, and then a review day, and then the test. So test coming pretty quick. So 3 more classes, or 2 more classes, and then the test day. Everybody's okay? Just giving you a heads up. Classes only meet twice next week, provided there's no snow days or whatever. So the test wouldn't be until the following week. Okay? I don't know. It's just getting to that time of the year to where it's like, I'm going to caveat everything being like, there's 4 scheduled days of school, so this class meets at most 2 times next week. And if there's a, snow day or cold day or whatever. All right. Reese, for you.
Well, that happened in like 7th grade. I remember that. I know. I know. Good day.
Okay.
I took a week off school. It's so